Alrighty, hello everybody. So what I've done here today is I took the notes from earlier and I'm going to walk us through how we got the answers. I kind of like this better. You can feel free to give me a comment on it because it actually helps you see the process that our scholars went through to get the answer. So what we did today was we translated verbal expressions, which means a sentence, into an algebraic expression, which means having numbers and variables and things add together and multiply together. Whatever it may be, we're converting these sentences into algebraic expressions. So in step A, we had 7 decreased by 3 times some number. So some number we define as x, that's just a variable, and we multiplied that by 3, and that's how we got 3x right here for step A. And then we did 7 minus the number because we had 7 decreased by 3 times some number. So instead of 3x minus 7, we had 7, that should be minus sign, decreased by 3x. So we took 3x away from 7 to get 7 decreased by 3 times some number. So that's how we did our first one there. For B, we had twice the difference of P and 10. So difference means to subtract. So we took 10 away from P and had P minus 10. And then we took twice that difference. So we did 2 multiplied by the values of P minus 10. That's how we did that one there. For step C, if I can never change my pen color, we found 4 times the sum of 3 and x. 3 and x we add together because sum means to add things together, and then we had 4 times that total value there. So we had 3 plus x, and then we added those together, and then we would take we would multiply that by 4 to get 4 times the sum of 3 and x. For step D, what we did was we did 10 less than twice the number 2w. So we had 2w, and we're taking 10 away from that. We said 10 less than twice the number because if you watch the video that I posted above this, we would be taking 10 away from 2w. We have 2w and we're removing 10 from that. For E, this is my personal favorite one. For E, we had the sum of a number squared and twice the number. And here you can see how we broke this down. For twice the number, we have 2x, and for a number squared, we have x squared. And so to find the sum of that, we're going to add together x squared and 2x, which when we combine them gives us x squared plus 2x. So we broke this down in each part. For this part, we did a number squared as x squared, and twice the number is 2x, and we just added those together. Alrighty. For step F, or for question F rather, this one says the quotient of 3 times a number, so that became 3x, and the quantity of 4 plus the same number, which is 4 plus x. So here we have 3 times numbers 3x, and the quantity 4 plus the same number is 4 plus x. We found the quotient there, and we know that quotient means to divide. So we divided the value 3x by our quantity 4 plus x. We had to find the quotient between this and this value here. And then for G said the following. If I could ever change my pen color. 5 less than a number, all multiplied by the quantity of 3 times that number. So 3 times that number gives us 3x. And then 5 less than a number is going to be x minus 5 is 5 less than a number. So we need to multiply them together to get our answer. So that was going to be 3x multiplied by x minus 5. And that is how we approached that problem. So this is how we converted our verbal expressions into an algebraic expression. There was no hard and fast way to do any of these problems. You kind of have to piece through each of them, but the key here is to break it down each time. This is why throughout the year I really emphasize annotations and breaking it down because it now is going to be super valuable for us moving forward. Alrighty, when we looked at question number 2, what we did was we matched together, I'm going to do this in black, we matched together each of our pairings. So for A, we had 2 times x minus 2, and you had to match it up. So A went to 2, B went to 3, C went to 1, and D went to 4. Now because choose any number, that's going to be x, multiply it by 2, so 2 times x, and then take that value and subtract 2 from it. That's why we have our connection there. For this one, we have 3 times quantity x plus 5 is because we choose a number, we add 5 to it, so that's that first step here, and we multiply all of that value by 3 on the outside. For step C, we choose any number and subtract 2 from it, that's what we do right there. And then we're going to multiply that by 2 on the outside, which is why we got that to be 1. And then our only remaining one was 4. So this was, A was 2, B was 3, C was 1, and D was 4. Alrighty, awesome. Question number 3, I want you to pause and see if you can understand why we got the answers that we did. I want you to pause this one here. I'm assuming we've now looked through the problem and tried to understand it, and our problem says the following. Write two expressions to find the perimeter of a rectangle with a length of 8 millimeters and a width of x millimeters. So to find perimeter, we need to add together all the sides. We are not doing area, which is length times width. We are absolutely not doing that by any means. We are not multiplying anything here. Find perimeter, we need to add together each of the sides of a rectangle. So this is the one that I like the best. We did 8 plus x plus 8 plus x. We add all this together, and that's going to give us our perimeter. We could also modify that to be 2 times 8 plus x. If you see here, we have two 8 plus x's. So we can just take one of those and multiply it by 2 to get 2 times 8 plus x. These are the two that I think are most important, the one that I would emphasize, so worry less about these. But if they're helpful for you, you can also check those out as well and think through why those might have given us the right answer. Alrighty, questions 4 and 5. Once again, I want you to pause and see if you can answer these independently. Pause and answer them independently. Alright, we're looking at question number 4 now. Write an expression that can be used to represent the width of a rectangle if the width is half the quantity of the length, L is our variable, and L is going to represent the length, increased by 2. They're going to value the width if the length is 8. So, our width is going to be half the quantity of the length L, so that's why we have 1 over 2L. Then we're going to add 2 to it, and that's how we find our width. We take half the length and we add 2 to it. That's given to us in the problem. So what if our length equals 8? How do we find the width? Well, we would substitute in our values. We're going to substitute in our values there. So we're going to have 1/2 times 8. That gives us 4. We're going to add 2 to that, and that gives us a final answer of 6. So if the length is 8, the width would be 6. And final question here, it says, write an expression that represents the following verbal description. 8 multiplied by the sum of a number and 12. So our number, we're going to call x. We're going to add 12 to that, and like we did earlier, we're now going to multiply 8 by the sum of these values here. So that's how we got 8 times x plus 12. That's going to be it for today. If you have any questions, make sure you come to my office hour session. I'm going to post another video for you to watch first. Thank you very much again for coming, and I will see everybody on Monday. Have a great weekend, everybody.